Okay, so our learning goal for today, or what the big picture of today is using a table of values. So there's three methods to graph. One, using your slope y-intercept and graphing the equation by plotting the y-intercept using your rise over run. Second way is using your x and y-intercepts. The third way is using a table of values. Okay, so to kind of use a table of values, that was loud. We want to find at least 3 points on a line. 3 or more is always good. We're going to aim for 3. So it says here, are the following points 4, 7, or -1, -5 on the line? 5x minus 3y minus 10 equals 0. Does anyone remember a way as to how to check if points are on a line? If this is my equation, 5x minus 3y minus 10 equals 0. Remembering that ordered pairs, how do I label an ordered pair? Do you know what this, like the first number in an ordered pair represents? Curtis? X. And the second one represents? Y. So if I were to substitute this x and y into this equation, what should it equal? What should it equal? I'll give you a hint. It's right in this line. 0. It should equal 0. If it's on the line, you'll have a left side equals right side balance. So let's check this out. For 4, 7, so I'm going to sub 4, 7 into this equation. When I sub it into this equation, Autumn, what will I write? So I'm going to start with this, 5. Whoa, not 4x. So I'm going to write 5. And then instead of writing x, what will I write? Good. And then what comes next? Minus 3. Good. So Rachel, when I simplify this, what do I get? Okay, and Jeff, when I simplify that even further, what do I get? So what do I get when I do 20 minus 21 minus 10? What do I get? I get negative 11 is equal to 0. Is this balanced? No. So no, 4, 7 is not on the line. Why do I know that? Because negative 11 does not equal 0. Okay? I want you to try that now and see if the point -1, -5, is that on the line? So you're going to do the same thing. Sub -1, -5 into 5x minus 3y minus 10 equals 0. I want you to take a couple minutes and do that right now. Okay, what did we do? What did you write down next? Val? Good, so tell me what I'm going to write. Okay, when you simplify this, Vic, what do you get? Minus, so I have like, that's like saying negative 3 times negative 5. It's actually plus 15. And then equals 0. The other way that you maybe could have written this would have been like minus negative 15, which the two double signs would have eventually turned into that positive there. So then how does this simplify, Billy? Yeah, so is this point? Is this point on the line? Yes. So we would then write yes, negative 1, negative 5 is on the line. Because left side equals right side. Are we okay with that? Okay, so a table of values. This looks familiar to you, right? X, Y, a graph, right? And you're all nodding your head because it does make a lot of sense. So I have here, in order to use a table of values, we get to pick values of X, and we're going to substitute those values in for X to plot, to figure out our Y. So we need to isolate for y here. We can pick any x values we want. Now there's some special x values that we have to choose very carefully to make sure we get integers. So what we're going to do is we're going to isolate for y here. If you're asked, so basically when in doubt, the only time you don't really need to put it into y equals mx plus b is when I'm asking you to solve for the x or the y intercepts. So Trevor, you're up. If I want to rearrange this equation to isolate for y, what do I do first? Yep. I'm not finding the intercepts. I just want y by itself. So what do I have to move over first? A little bit, yeah. Okay, that's intercepts. I want to get this by itself, y. So I want to have y on one side, everything else on the other side. So what am I going to move over first or bring over? Okay, the 2x, right? So I'm going to move that 2x over. So what will I have left on my left-hand side after I bring that over? Good. Equals? Minus 2x. Now I still haven't isolated for y. Jess, what do I have to do next? No, those aren't like terms. There's a negative in front of there. What do I have to do with that? Do you remember? Eric? Very good. There's a 1 in front here, so I have to divide everything by negative 1. Divide by negative 1. Divide by negative 1. Tiana, what happens to these negative 1s here? And they cross out, so I'm left with? Very good. Okay, now this is an example of really you can choose any x values you want because this is all in integers. When we don't have integers, so whole numbers, then it becomes a little bit tricky. So usually what you want to do is pick a couple values before 0, 0, and after 0 when you have an equation like this. So if 0 goes in the middle here, you can, let's say, pick negative 1, negative 2, positive 1, positive 2. I'm taking a couple negative values, I'm taking a 0, and then some positive values. Now to determine y, Curtis, what will I do to determine y? I'm saying let x equal negative 2. Okay, good. So what will I write? Very good. Okay, Malcolm, what do I get when I do that math? Pardon? Put it in your calculator. Tell me what you get. Put the whole thing in. I don't really need to see the steps here for this. I'm going to say that that's okay. I put in my calculator -5 plus 2 times -2. So what do we get? Good. So I have here y equals -9. So my ordered pair for this now becomes -2, 9. Andreas, what will I write for my next one? And Joanna, what do I get when I simplify this? Good. So what would my ordered pair be there, Joe? -1, -7. Good. You guys are on the ball. Good stuff. Okay, Kristen, what do I do for the next one? Good. And Paula, what do I get now when I do that? 0 times 2 gives me what? 0 times anything gives me 0, so -5. So my ordered pair here would be 0, -5. Valeria, what do I do for the next one? Good. And Ida, what do I get for that? Very good. So my ordered pair becomes what, Ida? Good. Okay, Autumn, what do I do for the next one? Which gives me what? Rach? Good. So my ordered pair is? Excellent. Okay, I want you to take a minute and I want you to plot those values. See if we'll get the same line. So when I say plot the values, you're going to plot the ordered pairs to graph that line. So my first ordered pair is -2, -9. Where is that on the graph? And that's not on the graph. So if it's not on the graph, skip it and go to the next point. -1, -7. How many of you have something similar to what I have up on the board? Okay, good. Does anyone have any questions about what we just did? This is pretty straightforward. Again, you could have picked any values of x that you wanted for this example. We're going to do another one that maybe isn't quite as easy. So my first step here is I have to isolate. So Jeff, if I want to isolate for y here, what do I have to do? I'm not subbing anything in. I have to get it into y equals mx plus b. So I want this y by itself, so I have to move some things over. Pardon? The 4x. And what else has to come over? The negative 10. Good. So Val, when I bring those things over, how will I rewrite that? Good. Vic, I'm not completely done. What do I have to do next? I need to get y by itself. Good. So I divide by 5, divide by 5, divide by 5. So Joe, what happens to these 5s on my left-hand side? Good. So I'm left with just... Now, does this work out to be a nice number here? No. I'm going to leave it as a fraction. I'm not going to turn it into a decimal. If you are asked a table of values questions and you're given a fraction, you leave it as a decimal. So I'm going to put this as 4 over 5x. What does this simplify to, Joe? So I don't write just 2. What do I write? I can't just put this. Plus 2. Good. Okay. Eric? Nope. Doesn't matter. Okay. Now, this is an example. If I were to put in 1 here, anyone know what I would get? If I were to plug in 1, what would I get? I have 4 over 5 times 1 plus 2. 1 times 4 over 5 gives me 4 over 5 plus 2. I would have to change this into a fraction. So it would be 4 over 5 plus 10 over 5. So I'm left with 14 over 5. Oh, yeah, sorry. It is negative. So I have negative 4 over 5, negative 4 over 5. So 6 over 5. What do you get when you do 6 divided by 5 in your calculator? 1.2. Is that a nice number to plot? No. So we're not going to do that. There's special values of x that we can pick, so I don't get fractions. I get nice integer numbers. Does anyone remember how to do that? What values of x I should choose? I'll give you a hint. It has something to do with the denominator. Anyone? Curtis? What you're going to do is you're going to choose multiples of, so we're going to use multiples of the denominator. So I'm still going to choose 0 here. And then if I pick multiples of 5, I'm going to choose 2 that are positive. What 2 would I choose if I'm doing multiples of 5? 5, 10. If I'm going to choose 2 multiples that are less than 0, what would I choose? -5, negative 10. So whatever your denominator is, those are the multiples that you're going to use when you're doing this. You typically always want to have 0 and then just go 2 before, 2 after. Curtis, is everything okay? There's no erasers. Okay, now I have to substitute this into my equation. Where did I leave off? Joe, you're up. So I'm going to write here y equals what? Okay, now we're going to do some simplifying here. We're going to get used to this kind of canceling out, crossing out. This won't cancel out completely. What this is saying to do is negative 10 divided by 5. Billy, what do I get when I do negative 10 divided by 5? Negative 2. So I'm just going to put a negative 2 up here. So my new equation will be y equals negative 4 times negative 2 plus 2. Okay, does anyone have any questions about what I just did? So I took what I'm substituting in, and I divided that by 5, because I can divide that by 5. It will always work. If you choose your denominator right, you will always be able to divide what you substituted in by 5. That gives me negative 2, which is why I put that there. Eric? Or sorry, Curtis? Yes, it would. If it was over 2, you would probably pick multiples of 2, so we would do negative 2, negative 4. We probably wouldn't go as high as negative 10. If I'm picking 2 before, 2 after. But yeah, it would. So we're choosing this number so that we always get a whole number when we divide it. No, this is, and then all I have to do is this. So you plug this into your calculator. Negative 4 times negative 2 plus 2 gives me what? Trevor, what do I get for that? Yeah. So I get 10. Okay, we'll do a couple more practice ones with this. So Jess, what am I going to write for my second one here? Good. So I'm going to cancel out. Eric, what do I do here? I'm going to cancel out this negative 5 and 5, or reduce it. So negative 5 divided by 5 leaves me with what? Not what? Negative 1. So on my next line, I'm going to write here y equals negative 4 times negative 1 plus 2. So Tiana, what do I get? Good. Okay, Curtis, you're up for this one. Yep. Okay, this should be a pretty easy one. What's the answer? Yeah, because 0 times anything just gives you 0. Oh, not 0. 2. Okay, Malcolm, do the next one for me. Good. So Malcolm, what's my next step going to be? Good. And what happens when I cross them out? What am I left with? Very good. Perfect. And what does that give me, Andreas? -2. Good. Okay. Joe, you're up. Whoa. You're like on super fast forward. Okay, so I substitute 10 in, good. And then I can do some reducing, some canceling out. What does that happen? Or what happens there? Some good? Good, which leaves me with a final answer of? Very good. Okay, so fractions are a little bit more complex, but we're choosing special numbers so that our life is easy. I want you to take 30 seconds and plot those. Okay, can't do the first one. We can do the second one. How many of you got something similar to what I have? Okay, that's good. Okay, we're going to do two special examples. Um, they kind of look a little different. Why does this line look different? What makes this one special? Okay, okay, let's eliminate this first one. If I have this, 4y minus 8 equals 0, what do we notice about this? Curtis? There's no x. I'm still going to isolate for y. So, Kristen, what do I have to do if I want to isolate for y? Good? Very good. Good. Y equals 2. Y equals 2. Huh. Anyone know what this looks like? Y equals 2. This is a bit of a special case because it doesn't have any x's. So it's actually like writing it kind of like this. Y equals 0x plus 2. Valeria? You're right. It's horizontal. So it's saying if I pick any value of x, because this is here, so I could pick -2, -1, 0, 1, 2. That's like saying all of my y values would be what? 2. Because it's like saying y equals 0 times -2 plus 2. Well, 0 times anything gives me 2. I can do that for all x values and see that y equals 2. So when I'm plotting this, I have here a horizontal line that looks like this, of y equals 2. I mean, they give you an acronym, which I just learned about this summer, which is kind of cool to remember these. The other one, so if this is my horizontal line, what do you think about this one? This one has no what? So what type of line do we think that's going to be? It's going to be vertical. So again, I can't solve for y here. I'm going to solve for a variable. Valeria, what will I do here? There's only one variable to solve for, so what do I do? -9, good. Good. So that's my equation, x equals -3. So if I have x equals -3, that's telling me that no matter what y values I choose, x will always be what? -3, -3, -3, -3. No matter what y values I choose, there's no y there. It's kind of like working backwards. I'm not going to fill in the y column, but it'll be a vertical line. Doesn't matter what points you choose. You can choose all of them or a couple as long as it's a vertical line. And a little trick that you can remember is this word, and it's a weird word. I'm going to give you a couple weird words this year. It's called Heuwachs. Sounds very, I don't know, German maybe? Heuwachs. So I'm going to write it down. Heuwachs. So what does this acronym represent? H, what do you think it means? Horizontal. If it's horizontal, it has what type of slope? 0. So it's saying a 0 slope. And it will always be in the form y equals some number. The Vux part, this is telling you that it is a vertical. Anyone know anything about a slope of a vertical line? We'll talk about it a little later. It's the letter U. Not unknown, undefined. And it will always be in the form x equals, so Heuwachs. That'd be a pretty cool tattoo. You could get that. I love Heuwachs. Don't tell your parents said that. I should go into a business. Okay, so that's just an acronym. If you had to do a table of values that would help you out maybe for horizontal, vertical lines,